This video is going to cover installing and deploying IntraVUE on a live network. I'm going to cover this in two ways. One, if you have a trial version 16 node limited, as well as if you have a full-fledged IntraVUE software. Now, the IntraVUE software can be downloaded and put on any computer, and the trial version has the product key already associated with it, whereas the live version or the fully functional version will require you to register the product. Once you install the IntraVUE software, you can click on and get this particular display either from a link that is on the computer's desktop that says Browse IntraVUE, or by putting in, if you are not local to the IntraVUE computer, putting in the IP address of the computer that's running IntraVUE, followed by the :8765. We do not use the standard port 80 Ethernet port for the web service to prevent the possibility of another web service being installed on that particular computer. In addition, the 8765 would allow it to be a unique number so that it could be added to a firewall or some other device, and it would be unique to viewing or browsing to the IntraVUE software itself. Now, once you have the IntraVUE system installed and you clicked on and got this particular screen, the next thing you're going to do is you're going to right-click anywhere on the background. And by right-clicking on the background, what it's going to do is it's going to bring up a menu. And two-thirds down the menu, there is going to be a selection, log in as admin. And by selecting that, what it's going to do now is it's going to take you and give you the opportunity to become the administrator. You cannot do any changes or configuration or anything to the IntraVUE software if you are not in the administrative mode. This means anyone can browse the IntraVUE software, cannot make any changes, but can get all of the information and keeps it secure for those who have the password. This password can be changed, but initially, when the software is delivered, the default password is IntraVUE, all lowercase. So that is INTRAVUE. And then when we select OK, what is going to happen is you're going to see a black outline around the IntraVUE display. And now when I right-click on the background, we're going to see additional fields popping up. The field that we're going to go to is the system configuration field. If this software has not been configured or registered and it's a new package, you would go down here to the Enter Product Registration area. And right now we're going to assume that the software has been already registered, and our intention here is to configure that software. So by selecting the system configuration, we bring up a window. This window has 5 tabs. The first tab, or the General tab, provides information about the IntraVUE product itself. The key code is a identifier that allows the IntraVUE system to know what size it is and what options have been selected for this particular IntraVUE. In our example here, the size of the IntraVUE software is 2,000 nodes. The key code is a unique code that's received or retrieved from the computer that's running the IntraVUE system that, along with the product key, are required to be registered, and that registration number entered into the IntraVUE system that enables that particular product key to work with this particular computer. And that was the field on the bottom, as you saw, for registering it. Now, below that, there are 6 what we call user-defined views. However, views 4, 5, and 6, so the last 3 views, are reserved for applications that support Ethernet IP, or the SIP protocol. And what will happen if there are Ethernet IP devices, the IntraVUE software will communicate to those devices and obtain the vendor, the model, and the revision level for that Ethernet IP device and store it in those particular data fields. The upper 3 data fields are used for you to create additional identifiers for each of the devices. So if you have a lot of a particular device, an I/O module or an Ethernet card on a PLC or a drive system, and you want to be able to distinguish one drive from another, you can set up categories and then add that information by each device. So categories would be things such as, I would like to put a description about that device and add that per each device. Or maybe the function of that device. And maybe the third one, we're going to go in here and we're going to say we want it to be owner or group about that device. So that information then, once this system is installed, we'll have those as headings, and those fields then can be filled in to provide useful information. It also is used in the search field, so you can search specifically for a particular device or a function or a description or all of the devices that are associated with a group or an owner. And then you can then scroll through that. So that's how it's set up there. The bottom here is the hover text, where you would then hover over a device, and by hovering over it, you have the ability to allow it to give you maybe the name or its IP address. But if you are going to be using the device name as the primary, then it may be more important maybe to have the IP address and the model number appear on that. And that's very flexible, and you can change that at any time. It's not part of the scanning process. The second tab is a tab that allows you to back up, restore, and clear databases. The IntraVUE software acts like a network data recorder. Once it's put in and running, it's going to run 24/7 and gather all information on a 1-minute resolution. That includes the transmit and receive information, ping response time, ping failures, and any moves, anything that's happening on that network is stored in this relational database. That information is then saved and can then be brought and viewed at some other point in time. So, for example, if I started a scan and I wanted to back that database up after scanning a particular area, I would then hit the backup. I would then put in the name of the file name that we would like to save it. It's going to save it under the C directory, IntraVUE database backups. So we could say this happens to be a October acceptance test. And I could then save the data off on here. We're not doing anything at this particular point, but I can save that, and you'll see that go in there successful. And then I could then restore that, and by restoring this, I could restore it in an offline mode, as you can see right here. The IntraVUE software, any database that is captured in the IntraVUE system can be sent electronically and put into any other IntraVUE system, even an IntraVUE system that does not have a license key. It'll act as a sort of a reader. It'll essentially give you the same viewing as if you were running the IntraVUE at that point in time when that backup was made, and then that is being done in an offline mode. Reasons for that would be, as I said, acceptance tests, maybe some histories that you're looking for, looking back in time to see how that network looked a year ago. and so on. So you have these capabilities of backup and restore, and also more importantly, the ability of taking any of those backup and restores and allowing it to be loaded on any computer, even a computer that does not have a license key, and then you can use that for planning purposes or analysis. The next tab is the default tab. As I mentioned, we monitor specific parameters on these networks, and this is done on a minute-by-minute basis. So we have a very good high resolution in identifying issues. The three parameters that we're monitoring are the ping response time in milliseconds for each of the devices, the ping failures, which would give us information on connection faults. That's set at 20%. Ping response time here setting is at 30, and then the transmitted and bandwidth percentage is set at 30%. And these are just general averages. If you'd like to make a change in that, for example, if you had a lot of wireless devices and want to make that 800 or something like that, you can make that, or make it smaller, whatever. So this is applied initially upon the initial scan, but yet you can change by connection any one of these parameters on a connection-by-connection basis. This just sets the defaults for the initial scan. The next item here is the email. I'm going to skip past the scanner and go directly to the email area. And what this does is it allows the IntraVUE system to send an email alarm if a device should stop communicating. If that device should clear and come back online, we have the ability also to put in seconds to wait. So after 30 seconds, if that device is still offline, it will send the email. If, however, it came back online, then the email will not be sent. We have both default email addresses as well as individual email addresses that can be sent on a device-by-device basis. And then if you are choosing the email option, you would then need to put in the SMTP authentication, the email server location, and once that was placed in there, you could then go and send a test email message to make sure that everything is working fine. So let's go back to the real part of what we're looking at, and that's the scanner. We're going to now go in there and use this. This is where you would configure the IntraVUE to go out and scan a network. A couple of things in this particular tab is the first one is the read-only community. This is for SNMP devices, primarily the switches as well as the other connected devices. And with this read community, especially on the switches, it allows us to gather information from those switches that give us the topology and allows us to map out the network. The standard default for most devices is public. We're using that in our office here. But for the most part, if you are in a manufacturing environment and have network people, this will be changed to some other password, and you would need to get that information on that particular system so that you can then start to get the information from the switches. Once you get the information from the switches, you can then reset this to public, and you can pick up other devices that may not be using that read-only password. Now, we don't, in SNMP, they have both read and read-write communities. The read-write allows us to communicate or write to a switch or an SNMP-enabled device. We do not require that. Matter of fact, we don't even try to use that. We want to be passive on our system. We don't want to provide information to individuals that could then go in and make changes. We are wanting only to get the information in a read-only way. And in most manufacturing locations, the read community will be different than the read-write, and it'll be very important, though, to get the read-only community. The other element to this is the scan speed. Initially, all of the IntraVUE systems are set for slow, and this is set so that we can handle very old 15, 20-year-old PLCs or other devices that are communicating at 10 meg half duplex. We don't want to create any problems with those. But for the most part, medium is working fine. If you want to understand what those speed settings are, in the help button down on this field here, you can select that, and it will actually take you and explain the amount of ARP traffic and the delays between the pinging for each one of the speed settings. So once we've set that up, we're now looking at trying to go add networks. You can add multiple networks. IntraVUE can have one, it can have 50 networks. You would set each one of them as a separate network. So I would hit add here. And in this particular area, the first thing we're going to be looking at doing is providing a network name so that it makes it easier when you have multiple networks to know which one it is. Because in the event log, as well as in other areas, the networks will be referenced by this particular name. So in this case, I'm just going to go in here and I'm going to call this the demo network. And I could then just go in there and have that. Now, the scanning of the IntraVUE system can be either local or remote. So in the easiest case is when the IntraVUE computer is on the same network that you want to scan. So it's local. And if you're local to the network, you would use the IP address of that particular computer. IntraVUE automatically finds the IP address of the computer. And if I click here, you can see if I have other network addresses, where they would be set up and shown in this particular fashion. In this case, I have a 51, and the 91 is my wireless on my laptop. So I'm just going to choose the 51. So, we have this ability of going off and using local. Now, if the IntraVUE is not local, or if you're scanning multiple networks or multiple VLANs, you would then not use the local computer. You would use the gateway address, which is the router address to that other network. Now, if you're not sure of the gateway address for that subnet, what you can do is you can take an IP address from that network and do a trace route. The trace route will then go through and give you the last hop router, and that would be used in this particular area to put in the access to that network. And you would do that for each of the networks. So in a VLAN, you might have each VLAN will be to the same layer 3, but that layer 3 might have a gateway address that's different and part of each of the VLANs. We're not going to do that at this point in time, but if you'd like more information on that, we have a lot more information in regard to deploying the IntraVUE system with multiple VLANs. The third option we have is in the ability to scan using what's called the agent. The agent was developed for non-routable or fully isolated networks or OEM networks that reuse the same IP address range over and over again. So, for example, if you were a PLC-IO network that was using 192.168.1 and the rotary switch was going to be for that last octet, each one of those IO networks will be the same, and then you wouldn't be able to use it for a router, and they would not be routable. So what you would then do is use an agent which has two Ethernet addresses. One would be the IP address that's facing the IntraVUE system. So let's say it's the 10.1.1 network, and let's say this is 56. And then when we go into the scan range for that, we would put in the 192.168.1 range for that, so that the interface to the agent is on the 56 side, and we're scanning the 192.168. Now we also need to then put a group number, because remember, these networks are repeated over and over again, so we have to distinguish which one they are. So we give it an index number, so you can increase the index number. And in this case, let's say if it's 3, we might want to go in here and call this PLC IO 23, and then have that information in that network range. But in our case, I'm not going to do that, but I'd like to show you that there are 3 elements. There is using the computer locally, using the router to get to the remote address if you're not local to the network you want to scan, and you have VLAN applications. This is predominantly the way VLANs would be set up, and the agents would be used when you have these non-routable networks. So we're going to go in here, we're going to delete that out of here, we're going to cancel that back out. I'm going to go back to add the network here and network 51. We'll keep it just pretty simple. I'm going to now add the scan range. I'm going to add the 10.1.1 scan range. Now, if I was using this in a 16-node demo version and I had 50 devices, if I left it this way, it would find the first 16 and stop scanning because it's limited to the 16 nodes. You may, in your testing though, may want to look for a switch or a couple of switches and some devices connected to see how that would map it all out. And in doing that, what you would do is you would essentially pick those out. So for example, if the switch happened to be 23 and 24, I can go in there and say start from 23 and go to 24. And so I can add those switches. And then I can say that the devices I want to add on here is device 110. And I can make it individually 110. I can say I can add another one that's 114, and I can add 114 in here, and so on. I can repeat this back and put in the 16 devices that I want to use for the trial version of the software. I'm going to delete this now because we have a full-fledged package. I want to show you, automatically how it would do in finding a full network. And so what I'm going to now do is I'm going to add the full Class C range, and I'm going to then add another range, and not a range, but a layer 3 device, 192, 168, 200, and then I'm going to make that 174. And over here, I'll make that 174 here. And this is a layer 3 switch that we have in this particular network. So you can see we added that. This is good because what you would normally see is that you might have in some applications the connected devices in a subnet, but the switches might be in a different subnet altogether. And if that were the case, you would then put in the IP addresses of those switches, and we could then use SNMP to get the MAC address, which would not necessarily need us to use the router. So there's a number of things that we've built into the IntraVUE system to allow it to solve issues in a variety of different ways. So at this point, we've now put in the 10.1.1 network and one device, the 192, 168, 200, 174. We're going to say OK. Again, we have the public as the read community for our system here. I'm then going to say apply and close, and that's all that we need to do for this IntraVUE system to start scanning. We're in the IP view right now, so what's going to start to happen is you're going to start to see the IntraVUE system finding all of the various devices that have been defined in that IP address range. And you can see the 10.1.1 51 is the IntraVUE system and all of these devices, and they'll continually be added initially to underneath a box called unresolved. Unresolved means that they've responded to a initial ping, but I don't have their MAC address. So as we're getting the MAC address, and in most cases, if it's local, it's going to be the ARP cache of the local IntraVUE computer. But if there are devices that are left in unresolved, it means that there's some type of error, either a subnet mask not set properly, or a firewall, or something that's preventing the IntraVUE from getting the MAC address of that device. And so we're starting to see all of these devices coming underneath the top parent. If I right-click now on this and go to Device View, what you'll start to see is the IntraVUE system is picking up the names of the various computers from the net BIOS. And so you'll see a lot of naming conventions here that are the net BIOS. And then in a few minutes, what you should start to see is green outlines being placed on devices that have SNMP management. So the Simple Network Management Protocol, they'll respond back. We're going to be asking those devices for specific questions. When we're getting those answers back, we're going to be putting green outlines. In addition to that, if I right-click here now and go to the model number, you'll be able to see that even before we start mapping out, we're starting to see the various Ethernet IP devices, 1794, 1763, and so on, showing up here. And you'll also notice that some of the Ethernet IP devices from Rockwell have the green outlines, which means that they are also supporting Simple Network Management Protocol. Now I'm going to go back to Device View, and what you're seeing now is the IntraVUE software picking up the SNMP-enabled devices. Many of them are switches, and in our lab we have 3Com, Dell, Cisco, Hirschman, we have Entron, we have Phoenix Contact, Ethernet Direct, and so on. And when we identify a switch by communicating to it with the SNMP, we ask it questions, and when we determine that it's a switch, we then request for information about what MAC addresses are being reported on what ports of the switch. And with that information, then we build what's called a parent-child relationship, and we automatically map out the network. So what's happening here is we're doing this, and we're doing this continuously. Anytime a new device joins the network, it will follow the same process. It's going to show up under unresolved. It's going to move to the top parent, and then when it gets claimed by a switch or a location on the network, it will then move to its final location. And so you'll see that this process is continuous. This is a logical view. Nothing is drawn. If you move something to a different location, it will move back, because what we're getting here is the switches telling the IntraVUE system how everything is configured. And so you're going to see here, now we now have a fully mapped out network, literally within a few minutes of deploying this on this network. Now, a couple of other things in regard to this. You're going to see that there are these NA nodes, which are essentially, if I bring this to an IP view, you're going to see that these are placeholders for IntraVUE, because what's happening is IntraVUE is saying that on port 11 of this upper level switch 1, it sees all of these devices. And so this could be an unmanaged switch. So anytime you might have a unmanaged switch connected to a managed switch, these will be the placeholders for that. Now, in addition to it being an unmanaged switch, in this case here, this happens to be a VM environment, a virtual machine, and the 250 is really the primary machine. So I can tell IntraVUE by going into the configure that this is a virtual machine. It could also be a web-managed switch, or a switch that does not have the bridge MIB, so it shows up as one of the peers, and we want to elevate that upward. And so I do an apply and close. And so what will happen is the 250 will shift up and replace the 193. so that so now you have the physical computer that's running the VM application all in there, and then the various virtual applications running underneath it. And so you have this full mapped out network. It happens, you can see relatively quickly. Again, if I go to the device view names, you can see the various devices. Again, if you go over to these devices here, you can then see by going to the properties what we automatically get. We get the MAC address, the IP address of this device. It happens to be a 1794 Rockwell device. We also discovered that it has a web link, and I can click on that, and I can bring up the active web link for this particular device, and so on. So I have all this information that is automatically retrieved, and you can see information that could then be manually added, such as description, function, and owner, to make it a little bit easier to find a device, as well as web links here that allow you to link to documentation and manuals or anything else that would make it easier for an individual to support an application. Once we've mapped this all out, and again, you saw that we've done that at a relatively quick pace, you can then go to import export, and wouldn't it be nice then, literally in minutes, to be able to output that information into an Excel spreadsheet where we would have every IP address on this network, the MAC address of the device, the switch that the device is connected to, the port on the switch which that device is connected to. If this happens to be another switch, what its uplink port is going back upward, and the name of the device on this system. And then as we go through here, you'll see all the devices that support web links, and you can see there's a lot of devices today that support web links, and we're going to automatically discover those. If the device has a location that typically is in SNMP, you can fill out location information, and then if we continue on down here, you can then see the vendor, the model, and the version of all the devices in this particular network that have been discovered. And so we have a way of being able to automate all of that information. And then if you come over here and you say that over here there's no name in this particular device, it's a 10.1.1.141. I want to give it a name. I would, most people will have another spreadsheet with IP addresses and what the device is. You can fill this information in here. You can also put descriptions, fill in the descriptions for this, or the function, or the owner, and then I can re-import that information back into the IntraVUE system and have that all available. So after we map this all out, going back to the original discussion, and you want to go to a different network, or you're looking at an OEM machine and you want to go to another OEM machine, you can then again go to the system configuration. You can then go in here and go to the database, back this database up and say packaging machine 23, and I'll save the packaging machine 23 and store that information in here, and then clear the database and start another scan, move to another network, and so on. So that's a little bit of a quick overview of the IntraVUE software and how it automatically discovers and maps these devices. I appreciate spending the 35 minutes to listen to it, and please contact your local Panduit representative if you have any other questions. Thank you very much.